So some of you may have questions on lesson 92. So 92 is talking about how we're going to take all of the components that you've learned. You've learned how to do gram formula mass. Okay, gram formula mass is ultimately just calculating what the mass of each element is in a compound. You've learned how to do moles to mass, and hopefully the reverse as well. So this component is tying it all together. So we need to look at what reactants we need, how much reactants, to ultimately calculate what number of products we're going to produce. So this is where moles kind of is important to know. Now you might be starting off and looking at this word molar mass. Don't be confused by it. Anytime you see the word mass, you can assume it's grams. So for each of these, we're going to look at what the gram formula mass is of both the reactants and the products. So for our reactant, we have calcium, which is 40, and we have 2-chlorine, which are 35.4. So rough math, plus 70, it's roughly about 110 grams. NaOH, we have 23, 16, and 1. So we have 17 plus 23, so that's roughly going to be 40 grams. Calcium hydroxide, so this is going to be 17 times 2. That's going to be 34 plus 40, roughly about 74. Okay. And NaCl, Cl is going to be 35, and Na is going to be 23. So once you have that all set, you have the actual basis as to how many grams of reactants you're going to need to make the products that you're going to get. So in this example, they're using a root canal. So these are the two substances that they use in order to make the fillings that are in your teeth. So taking a look at not only the molar mass, we have to be considerate of what's going on in the chemical equation. So we know that there is 1 mole of CaCl, 2 moles of NaOH, and you can see it again going back to the original equation. 1 mole of calcium hydroxide and 2 moles of NaCl. So as we go through this, we're going to be looking at both the moles and the mass. So let's take a look. They give it to you. They tell you that there's 1 mole of CaCl2, 2 moles of NaOH, 1 mole of CaOH2, and 2 moles of salt. We've also calculated, I was off by 111 grams of CaCl. You have 2 moles of NaOH, and so what happens is we had to take 2 times the 40 to get to that many grams. Okay, so for every 1 mole of calcium chloride, we need 2 moles of NaOH. So we take the gram formula mass and we multiply it by the number of moles. That's how we get to 80. Looking at the product side, we have 1 mole, 74, good there. And this one, you'll do the same thing. We had 58, for that's 1 mole. Now we have 2 moles, so to get that, it had to be 2 times 58. So let's go through a couple of these and see how well we do. So as always, we're going to have 1 mole of calcium chloride. Okay, but what happened to the mass here? The mass halved itself. So what we need to do is we need to half the mole. Now we don't write in fractions. We are going to delete that and write it correctly. And that's going to be 0.5 moles. Okay. So now we're working with half the amount. Okay. So if we have half the amount, which would be 1, half of 1 is 5, half of 2 would be 1 mole. So if we have 1 mole of the substance, we have 40 grams. Okay. And again, going along with this, we have 55.5 grams. Okay, that's good. Looking at the reactant side, this is also 1/2, okay, 0.5 moles. Therefore, this must be 1 mole of our NaCl. Okay, this one is a fourth, or no, this is a fifth of the amount. So we can ultimately do it this way: 0.100 moles. Okay, and if you weren't sure, we know that it's a 1-to-1 ratio if we look at the calcium chloride to the calcium hydroxide, and this would also be 0.2 moles. Okay. So I'm going to leave this with you, and you're going to have to figure out what a tenth of 111 grams would be. Okay, and you have to figure out what would be a tenth of the 80. Okay. If you have any questions, let me know.